Welcome to 360 Industrial Services New Hire Orientation.
Our first subject today is going to be on hazard communication. This is your right to know about the chemicals that you're going to be using in the workplace. Session objectives. After we're done here, you'll be able to understand the information contained in a material safety data sheet, obtain specific applicable information on hazards and chemicals in your work area, interpret information on warning labels, determine physical and health effects for chemicals used at your work and the PPE required to protect yourself, understand chemical emergency procedures, and employ proper chemical disposal methods.
HazCom Program Requirements. As your employer, we are responsible for preparing a written hazard communication program, evaluating all chemicals imported or produced, employee training such as this on the hazards identified, the labeling of containers, and compiling a master list of hazardous chemicals, as well as keeping MSDSs available to all employees at all times.
We also have some HazCom program exemptions. This is where chemicals are covered by other regulatory standards. These include pesticides, food and food additives, drugs, cosmetics, wood products, alcohol beverages, and non-hazardous articles as defined by OSHA. Employee requirements. As the employee, you must be able to read the labels in MSDSs, follow employer instructions and warnings, identify hazards before starting a job, and participate in the training such as this. HazCom definitions. A hazardous chemical. Any chemical that poses potential physical or health hazard. A physical hazard. Any chemical that has been identified through scientific study to be combustible, flammable, explosive, a compressed gas, organic peroxide, oxidizer, pyrophoric, unstable, or water reactive. Health hazard. Chemicals that have been identified through scientific study that either have an acute or chronic health effect on employees. MSDS overview. This is where we're going to show you the different sections of the MSDSs and what they mean to you. Typical MSDS sections include the product and company identification, the hazard identification, composition information on ingredients, first aid measures, firefighting measures, accidental release measures, handling and storage, exposure control, and personal protection. Other sections include physical and chemical properties, stability and reactivity, toxicological information, ecological information, disposal considerations, transport information, regulatory information, and other information. Product and company information. This section includes the material and links the MSDS to the label and shipping documents. It also identifies the name of the manufacturer, importer, or other responsible party, along with a mailing address and a phone number for obtaining additional information. Hazard identification. This section describes the material's appearance and most significant immediate concerns. It is divided into 4 subsections: emergency overview, OSHA regulatory status, potential health effects, and potential environmental effects. Composition and ingredients. This section identifies the components, byproducts, and impurities that contribute to the material's hazards. Chemical name, common name, or synonym, along with the corresponding chemical abstract services, registry number, and percentages or ranges of percentages are included. First aid measures. This section is divided into 2 subsections. First aid procedures. The first aid procedure should be brief, easily understood emergency and first aid instructions for each potential route of exposure. They are intended for use by any untrained individual. Notes to physicians. The notes to physicians convey additional information and antidotes on specific treatments and diagnostic procedures and are intended for use by healthcare professionals. Firefighting measures. This section describes the specific hazards arising from the fire and explosive properties of the material, the appropriate extinguishing media for the fire, special protective equipment, and precautions for fighting fire. Accidental release measures. This section contains information for responding to spills, leaks, or releases in order to prevent or minimize the adverse health effects on persons, property, and the environment, including personal protective equipment, containment equipment, cleanup equipment and techniques, environmental precautions, and special reporting requirements may be included. Handling and storage. This section provides guidance on safe handling and storage practices. Precautions that are proper for the unique properties of the material should be emphasized. Exposure control and personal protection. This section is divided into 3 subsections. Established exposure guidelines for the material and/or its components, engineering controls that may be appropriate to help minimize the hazards, and personal protective equipment guidance, eye, face protection, skin protection, respiratory protection, and general hygiene considerations. Physical and chemical properties. This section identifies the physical and chemical properties of the material. For example, its appearance, odor, pH, flash point, flammability, upper and lower flammability or explosive limits, specific gravity or related density, autoignition temperature, and decomposition temperature. Stability and reactivity. This section describes the potential hazards associated with the stability and reactivity of the material under specific conditions. Chemical stability, conditions to avoid, incompatible materials, hazardous decomposition products, possibility of hazardous reactions should be addressed. Toxicology information. This section provides toxicological information that can be used to assess human health hazards or potential health effects of the material and/or its components. The acute dose effects, repeated dose effects, irritation, corrosivity, skin and respiratory sensitization, carcinogenicity, neurological effects, genetic effects, reproductive effects, developmental effects, and target organ effects data. Ecological information. Information to assist in the evaluation of environmental impact of the material and/or its components if released to the environment is provided. Ecotoxicity, persistence and degradability, bioaccumulation, accumulation, mobility in environmental media, other adverse effects. Disposal considerations. This section provides information that may be useful in the proper disposal, recycling, or reclamation of the material and/or its container. Transport information. Basic classification information and special precautionary information to help a knowledgeable user prepare a material for shipment is given in this section. This section is not intended to contain every regulatory detail involving the transportation of a material. Regulatory information. This section provides information on the regulatory status that is useful for compliance with health, safety, and environmental regulations, such as the Clean Air Act, the Clean Water Act, the Comprehensive Environmental Response, Compensation, and Liability Act, also known as CERCLA, the Drug Enforcement Administration, the Food and Drug Administration, the Occupational Safety and Health Administration, also known as OSHA, the Safe Drinking Water Act, the Superfund Amendment and Reauthorization Act, and the Toxic Substances Control Act, and the United States Department of Agriculture. Our next subject in the MSDSs is labeling overview. General labeling. Do not accept any chemicals that do not have full labeling intact on your job site or facility. Information needed on the label. It must be legible, must be written in English, prominently displayed, identity of the hazardous chemical, appropriate physical and health hazard warnings, and the name and contact info of the chemical manufacturer or importer. The NFPA labeling systems. This is the fire diamond and fire hazard chart. The blue stands for health hazards, the red is the flammability, yellow is reactivity, and white equals other hazards, with a scale being from 0, no hazard, to a 4, to being extreme hazard. Chemicals come in different types and forms. These include solids, with dust and powder, fumes and fibers, liquids, like fluids and mists, and gases and vapors. Important physical properties. Flammable liquid, any liquid that has a flash point below 100 degrees Fahrenheit. Combustible liquid, any liquid that has a flash point at or above 100 degrees Fahrenheit. pH, the measure of the acidity or alkalinity of a solution with a scale from being 0, a strong acid, to 14 being a strong base. 7 is the pH of pure water, and that's neutral. Other important physical properties. Corrosives, liquids or solids that can cause destruction of human skin, tissue, or mucous membranes, highly acidic or alkaline. Vapor density, the measure of gas or vapor in relationship to the density of air. Gases with a value of less than 1 will sink, and greater than 1 will rise. Odor threshold, the lowest concentration at which a chemical can be detected by the human nose. Health hazards. Health hazards are broken up generally into two different categories of how quickly they could hurt or injure you. Acute, which is an injury or illness resulting from short-term exposure, and chronic, which is an injury or illness that occurs after prolonged exposure. Emergency procedures if you come in contact with chemicals. For your eyes, flush with water for 15 minutes. For your skin, refer to the MSDS. Most commonly, flush for 15 minutes. For inhalation, move to fresh air. Swallowing, get emergency medical assistance. This slide shows the different ways that chemicals can enter your body. Absorption through skin or mucous membranes, inhalation, ingestion, injection, which is, for example, penetration through a cut or puncture. Emergency response to chemical spills or leaks. Evacuate the area, notify a supervisor or the emergency response team, and stay away. If you're not trained to clean up chemicals, please do not attempt to do so. It can be dangerous to your health and further prolong the situation. Exposure limits. These are the limits that OSHA and other governmental agencies have determined that your body can be exposed to different chemicals for different periods of time. The permissible exposure limit, or PEL. This is an OSHA regulated value. Its concentrations are expressed in parts per million, or milligrams, or cubic meter. The threshold limit value. This is developed by the American Council on Governmental Industrial Hygienists. TLV, time weighted average. TLV, short-term exposure limit. TLV, ceiling limits. Key points to remember when referring to MSDSs or hazard communication. Identify chemical hazards. Read the labels in MSDSs. Follow warnings and instructions or ask your supervisor if you're in doubt. Use the correct PPE. Practice sensible, safe work habits, and learn emergency procedures. The next subject in the orientation is lockout-tagout training. In the refrigeration industry, lockout-tagout is crucial to your safety. The objectives of lockout-tagout training: to define lockout-tagout program requirements, understand why and when equipment must be locked out before servicing or maintenance, define role of affected and other and authorized employees, understand procedures to shut down and isolate equipment and release stored energy, and know how to apply and remove lockout devices. Example energy types: electrical, hydraulic, pneumatic, chemical, thermal, and gravity. Be careful. Just because we may only work in one type of energy does not mean that the work that we may do may energize other systems, or other contractors could energize our systems by the work that they're doing. So before doing any type of work, understand the energy that may flow and how it may affect you. Here's a frightening statistic. Failure to follow lockout-tagout procedures has resulted in 10% of all serious industrial accidents, 28,000 lost workdays per year, and the loss of 120 lives per year. We don't want to be one of those statistics. Working on an existing electrical circuit, equipment initial setup or maintenance activity, machines which can start unexpectedly, blocked or jammed machines, or anytime hazardous energy may be released. Lockout-tagout definitions. The affected or other employees. These are employees who operate equipment or may be in the area where servicing or maintenance takes place. They're required to have lockout-tagout awareness training. Then there's you, the authorized employee. You guys are employees who are authorized and trained to use lockout-tagout procedures to perform servicing on equipment or electrical circuits. As an authorized employee to use lockout-tagout, you have several serious responsibilities. You need to understand general lockout-tagout procedures, understand applicable energy sources and their magnitude, know methods and means to energy isolation. You must be trained in and competent on specific lockout-tagout procedures for equipment to be serviced, and you're going to be issued lockout devices, locks, and tags needed to safely complete servicing of equipment and/or circuits. Other definitions include energy isolating devices. This is a mechanical device that physically prevents the transmission or release of energy. Control circuits, such as push buttons and selector switches, are not energy isolation devices. A lockout device, a device that utilizes a positive means to hold an energy isolating device in the position.
As a contractor, we also have lockout-tagout program requirements. We must have a written lockout-tagout program, written equipment-specific procedures, provide your employees training, which is what we're doing now, administer appropriate disciplinary actions should you not conduct lockout-tagout properly, conduct annual certified audits of each authorized employee, the lockout-tagout program effectiveness, and the equipment-specific procedures.
OSHA allows for a cord and plug exemption if the equipment is powered only by a cord with no secondary power source. The only requirement is that the authorized employee unplug and maintain exclusive control over the cord during servicing. This would be a situation if you were changing a drill bit or changing a saw blade. By OSHA standards, lockout-tagout devices must be durable, substantial, standardized in color, shape, or size, identifiable, so you can't share a combination lock, and one lock on each energy isolating device for each authorized employee involved in the servicing. Pictured are a couple different lockout-tagout devices. The first one shows a disconnect switch with a lock and tag on it. The second picture shows a plug cap on a piece of equipment. As an authorized user of lockout-tagout, retraining may be required from time to time. You'll be retrained in lockout-tagout procedures whenever you have a change in job assignment or change in a machine or process which present new hazards. A periodic audit or safety incident identifies that you have a deficiency in your knowledge of lockout-tagout. All the training you receive will be certified and is going to include, along with the content, your name and the dates of training. Now we're ready for the steps to perform lockout-tagout. We need to notify all affected employees that lockout-tagout is about to start and stay clear of all the applicable areas. Next, we need to locate all energy sources and then isolate all those energy sources. Now we need to apply the lockout devices to all energy isolation devices. Test the devices to ensure proper installation. Tags must be attached to warn of hazardous conditions and provide authorized employee contact information. Now we need to verify that there is a zero energy state by operating any controls and testing the electrical circuits. Now we're ready to complete our work. If an authorized employee needs to leave the area, proper energy isolation must be re-verified upon return. Now that the work is complete, here are the steps to remove the lockout-tagout. First, remove all debris, parts, and tools from the area. Ensure all operational components are intact. Remove employees from the area, and then verify that switches and breakers are in the off position. Now we can remove the lockout devices, re-energize all energy sources, and inform the affected employees that work is complete and the system is ready for use. Your energy isolation device must only be removed by you, who is the authorized employee who installed it. The company lockout-tagout program includes specific procedures for emergency lock removal when an authorized employee is not on site or left the company, an authorized employee lost their lockout-tagout key, or an authorized employee that installed the lockout-tagout cannot be identified. In the event of an emergency where your lock needs to be removed from a device, the following procedures will take place. There'll be a verification that you are definitely not at the facility. There'll be a documented effort to contact you to inform you that your lock is going to be removed. There'll be a review with your supervisor to verify that the system is safe to have its locking device removed. And then there'll be a prompt notification to you once you return to the job site or your work area. This concludes the lockout-tagout section of the orientation. If you have any questions, please ask your instructor now. The next section of the orientation is on fall protection. Our objectives for the fall protection section are to describe working conditions where fall protection is required, identify the components of a fall arrest system, demonstrate how to put on and remove a full body harness, know how to inspect and care for personal fall arrest systems before and after use, identify safe and unsafe ladder practices, describe correct practices when ascending and descending a ladder, and describe correct practices for using extension ladders. The need for fall protection is obvious. About 40,000 deaths and disabling injuries result each year from falls. Falls are the #1 cause of fatalities in the construction industry. All employees shall be protected from falls 6 feet or more by the use of an approved fall arrest system. Engineering controls, which are controls used other than personal fall arrest systems, are also used to prevent people from falling. These include guardrail systems in hoisting areas, and warning lines. A guardrail system protects employees from fall hazards. It consists of a handrail, a midrail, and toe boards. It prevents workers from falling over the edge. A guardrail system consists of a top rail, a midrail, and a toe board. The top rail must be able to withstand 200 pounds of outward and downward force. It should be set at 42 inches, plus or minus 3 inches. The midrail should be capable of withstanding 150 pounds of outward and downward force and is at the midway point between the deck and the top rail. The toe board is 3.5 inches high and needs to be able to withstand 50 pounds of outward and downward force. Any hoisting area on the job site or at an elevated work area needs to be protected with a guardrail system. During the hoisting operations, a chain or gate or removable guardrail section must be in place. Prior to removal of the guardrail, the employee shall be protected by use of a personal fall arrest system. This means that you need to tie off before you remove the chain, exposing yourself to a fall. A warning line system is a barrier that is erected to warn employees that they're approaching a fall hazard. This is used in areas such as a leading edge work or on a roof, where your work is not on the edge of the building and no guardrail or fall arrest system is in place. Warning lines must be posted at least 6 feet away from the edge of the fall hazard, 10 feet if you're using mobilized or mechanized equipment. Warning lines may consist of ropes, wires, or chains that must be capable of supporting 50 pounds of force without tipping over. There are different types of fall protection devices. There's positioning device systems, fall arrest systems, and fall restraint systems. A positioning device system is a body harness system rigged to allow an employee to be suspended on an elevated vertical surface, such as a wall, and work with both hands free while leaning. Your employer, this company, does not allow the positioning device system. It is not to be used at any time. A fall arrest system is a system which limits free fall distance, thereby reducing the force on the body. It consists of an anchorage point, a lanyard, and a full body harness. An anchorage point is a secure point of attachment for a personal fall arrest system. An anchorage point must be able to withstand 5,000 pounds of force that may be placed on it per worker that is tied off to that anchorage point. An anchorage point can be many things in construction, but it cannot be any live utility system. No conduits, pipes, or ductwork. Your anchorage point should always be above your waist. If you don't put your anchorage point above your waist, it causes too much free fall distance and increases your chance of injury. Here are some pictures of different types of anchorage points. Now here, let's look at some improper anchorage points. Remember, we don't ever want to tie off to live utilities. No pipes, ductwork, or conduits. What is a lanyard? A lanyard is a flexible line made of nylon rope, wire, or nylon strap with a locking type, small hooks at each end for connecting the full body harness to a lifeline or anchorage point to stop the employee in the event of a fall. Your lanyard has some very specific and important guidelines. A lanyard must be inspected prior to each use, be protected against being cut or abraded, have a minimum breaking strength of 5,000 pounds, be the appropriate length, and be attached to an anchorage point and not to itself, unless it's an approved tieback type lanyard. A self-retracting lifeline and lanyard is a lanyard that automatically limits its freefall distance to less than 2 feet. It must be designed, constructed, and tested according to the American National Standards Institute or other approved testing agencies. A full body harness is a harness that straps secured about the employee in a manner that distributes the fall arrest forces throughout the body. It also prevents the worker from being doubled over or slipping out of the harness, such as the case with body belts.
Here's some more guidelines on the full body harness. The full body harness should have a D-ring that sits between your shoulder blades. Not too high and not too low. Any other way could cause some injury. The snap hooks should be of the locking type. This way it doesn't roll out. Body belts are not allowed by OSHA, and they're not allowed by Hill Phoenix. If you find one on your job site, please remove it from service.
It is extremely important that you inspect your fall protection system prior to each use. Hold the harness by the back D-ring and grasp the strap and run your hand along the entire length, checking for cuts or damaged fibers. Check the D-rings and their metal or plastic wear pads for any distortions or cracks. The D-ring should pivot freely. Inspect all hardware looking for loose grommets, distortion, cracking, or sharp edges. Attachments of buckles and D-rings. Look for any unusual wear, frayed or cut fibers, or distortion of the hardware. Inspect for frayed or broken strands. For the friction and mating buckles, inspect for distortion. The outer and center bars must be straight. We don't want any kinked or bent buckles. On a lanyard inspection, begin at one end and work to the opposite. Slowly rotate the lanyard so the entire circumference is checked. Look for knots, burrs, cuts, or fraying material. For shock absorbing lanyards, ensure that the stitching along the top and the bottom of the shock absorber is intact. This would be a sign that the shock absorber has been used already. For the hardware, look for all distortions, cracks, corrosion, or pitted surfaces in the snaps and thimbles. Ensure that the snap hook is properly opening and closing all the way. Care for your fall arrest system. After a fall arrest, equipment subjected to the fall will be removed from use to ensure that it cannot be reused. Clean equipment after each use with mild soap or water. Do not use harsh chemicals or solvents. Rinse with fresh water. Hang equipment in a cool, dry area that is dark and well ventilated. UV light and excessive heat will cause failure of the equipment.
Our next subject is on ladder safety. We use ladders every day to perform our jobs. Unfortunately, ladders can be one of the more dangerous tools that we use, because thousands of people are injured each year, and many are killed by falling off of ladders.
In fact, ladders can be so dangerous that each year in the United States, ladders cause an estimated 300 deaths and 130,000 injuries requiring emergency medical attention. That's an awful lot of people falling off of ladders.
Types of ladders. Most portable ladders are designed as a one-person equipment with the proper strength to support the worker, his tools, and materials. There are three types of ladders. A Type 1 industrial, heavy duty with a load capacity not more than 250 pounds. This is the type used by your company. Type 2 commercial, medium duty with a load capacity not more than 225 pounds. And Type 3 household. This is a light duty ladder with a load capacity of not more than 200 pounds.
In this photo, we see the different parts of a stepladder. From top to bottom, we have the top cap, the first rung, the spreader bars, the other rungs, the vertical support rails, which are the sides of the ladder, and the feet. If any one of these components is either damaged or not in place, the ladder is not to be used. Next, we have our 5 basic rules of ladder safety. Rule number 1, select the right ladder for the job. Choose the type and size of ladder for your intended specific purpose. Rule number 2, inspect the ladder before you use it. Make sure your ladder is rated to hold your weight. Check for loose or damaged rungs, vertical support rails, or braces. Check for loose screws, bolts, hinges, or other hardware. Make sure the ladder rungs have non-skid footing for stability to reduce slippage while you work. Check the ladder rungs for grease and dirt, which could cause slipping. If the ladder has any type of defect at all, it must be repaired or replaced. Never use a defective ladder. Rule number 3, set up your ladder with care. If you must set the ladder in a high traffic area, use a barricade, cones, or an attendant to prevent collisions. Post notifications or block any nearby door that opens towards you. The area surrounds the base should be kept uncluttered, and the ladder should be set on solid, level surfaces. The locking device on some ladders may present a pinching hazard, so keep fingers clear when setting up the ladder. Make certain the spreaders on step ladders are locked and in place. Rule number 4. Climb and descend ladders cautiously. Use both hands and face your ladder. Keep your belt buckle centered between the vertical support rails at all times. We call this the belt buckle rule. If you need tools, carry them in a tool belt or raise or lower them with a hand line and a bucket. Also, to avoid slipping, always check the bottoms of your shoes for slippery substances. In the event that you're working in a clean room, booties should be tightly secured to the feet so they do not snag, slip, or fold under, or present a tripping or slipping hazard. And finally, rule number 5, sensible ladder safety. Always maintain the center line of your body between the ladder's vertical support rails while working. Never climb higher than the second rung from the top of a step ladder without fall protection equipment. No matter what kind of ladder you're using, never leave an open ladder unattended. It could fall unexpectedly and hurt someone, including yourself. Also, while working on the second rung, keep 3 points of contact on the ladder at all times. When working safely from the third rung or below, 2 points of contact is allowed. Workers often ask, when is fall protection required when using a ladder? When using a stepladder to access an elevated location, you can use the first rung only, with a full body harness and a lanyard that is tied off to an approved anchorage point, and with a buddy stabilizing the ladder at all times. You'll also need fall protection if the work activity causes imbalance or requires pushing, pulling, or lifting. A full body harness and lanyard must be used to an attached approved anchor point. If an approved anchorage point is not available and the work being performed is over 6 feet, the buddy system must be used. When you're done using your ladders, make sure you store them in a well-ventilated area, laying down sideways to prevent sagging and warping. Secure ladders to wall brackets or chain them to the wall in a closed position. In construction areas, store ladders away from high traffic and in the closed position.
Ladder inspection. All ladders must be inspected before each use. All hardware, bracing, rungs, vertical support rails must be in good working condition before using. All ladders must be thoroughly inspected on an annual basis as well. The next brief subject is on confined spaces. A confined space is defined by OSHA as any space that has the 3 following characteristics. It is large enough for a worker to enter and perform their work, has a restricted means of entry and exit, and is not designed for continuous employee occupancy. No worker is to enter a confined space without prior training and approval. This is a complete separate course. Entering a confined space without prior training approval may result in your termination.
Often, in construction, we use mobile elevated work platforms. A mobile elevated work platform is also known as a scissor lift or boom lift. No worker is to use these types of lifts without first attending a training class. This orientation does not authorize you to use a lift of any type. This concludes the 360 Industrial Services New Hire Orientation. We will continue to strive to provide you a safe working environment. However, we will need your help by following the rules and procedures laid out in this orientation. Thank you.